Hi, have you ever wondered how calculus or math in general predicts the future? Like how we calculate the exact speed of a rocket or even the growth of pandemic? This is all comes down to this one particular calculus superpower, techniques of differentiation. Welcome back. So, what is differentiation? Differentiation is a process of finding the derivative of a function. The derivative tells us the rate of change, like how fast a function is increasing or decreasing at any point. It's a process in calculus where we would find the instantaneous rate of change based on one variable. Geometrically, it gives us the slope of the tangent line at any point on a curve. Super useful for real-world problems. But how do we actually find derivatives? That's where the techniques come in. And trust me, once you learn these techniques, you will literally see calculus everywhere. Ready? As you can see, there are many techniques of differentiation, but we are going to use only a few techniques to solve the upcoming questions, namely basic rules of differentiation, product rule, quotient rule, chain rule, differentiation of trigonometric, exponential, and logarithmic function, implicit differentiation, and even linear approximation. However, simply knowing the rules isn't enough. We got to use them. So let us solve some questions altogether and see how these techniques in real action. Grab your pens, and this is where things get real. Now, let us do question 2a, where the question is asking us to do for the function of y equals to 3x squared secant x plus 2, where we need to find the derivative or the differentiation of this particular function. So how do we solve this particular question? First, we need to identify what kind of function is this. So as you can see, we know that this is a product function. Where it is a product function, we need to use product rule, which is u v prime plus v u prime. Okay, so when we want to use this particular formula, we need to divide this function into two parts or two sections. We divide it into half, and then we assign this first part as u and the latter part as v. So now we can differentiate both sides. Okay, so when we already have all the values, we can plug in all the values here into the product formula. So let us plug it into that. So u. Okay, so is this a final answer? Well, it depends. Alternatively, you can simplify it more to become more simpler. So, how do we simplify the function? We can factorize. Can we simplify it more? Yes. We simplify. We divide all of this function with 3x. Okay, we factorize the common terms, which is 3x. So, 2, and then we rearrange it. So, this is the final answer after we already factorize it. Okay, so let us move to the next slide.
Next question will be question 2b. The question asks us to differentiate 4x plus 2 divided by cos x. First, we will be using quotient rule. Therefore, we will separate it into two parts, which is numerator will be u and denominator will be v. So, we will assign it to each one of it, which is u equal to 4x plus 2 and v equal to cos x. After that, we will differentiate both of it. So, u equal to 4 and v prime equal to negative sine x. After that, we will put into the formula, which is v u prime minus u v prime divided by v square. So we will put it inside the formula. Now we will multiply the inside of each part, and it have now become 4 cos x minus plus 4x sine x plus 2 sine x divided by cos square x. That's all from me. Thank you.
Now, I will move to the question 3, which says it's given us y ln 3x minus exponential power of 2x plus 1 minus tan 4y equal to 0. And it asks us to find dy over dx using implicit differentiation. Sometimes functions are given not in the form of y equal to fx, but in a more complicated form in which it is difficult or impossible to express y explicitly in terms of x. That's this question. So let's move on. So it's like this question, they have three parts, which is y ln 3x. The second part is exponential power of 2x plus 1. And the third part is tan for y. So let's do the first part. The first part is actually will apply product rule. The formula will be uv prime plus vu prime. So now the u for this one will be y and the v will be ln 3x. So when you differentiate y in explicit differentiation, it will be dy over dx for v prime. So ln, when you differentiate it, it will be 1 over 3. So then we'll need to multiply it with differentiation of 3x, it will be 3. So equal will be 3 over 3x. You can simplify it. It will be 1 over x. Now we just need to apply it on the formula of product rule. Now we already done the first part. We will move to the second part, which is exponential power of 2x plus 1. When you differentiate exponential, it will just be the same. So it will be exponential to power of 2x plus 1. And remember, this will also apply chain rule. So we need to differentiate 2x plus 1. So when you differentiate 2x plus 1, so now you guys need to multiply it. It will be 2 exponential power of 2x plus 1. Now, let's go to the third part, which is tan 4y. Now, if you want to differentiate tan 4y, it will be sec squared 4y. And this is also chain rule. So you guys need to differentiate 4y. Here will be 4 dy dx. Next, just multiply it. So now, let's go to the final part, which is actually just combine it. Combine it. So when you combine it, it will be y over x. Now, the goal for implicit differentiation is actually to have only dy dx on the left side. Let's put all of the terms that have dy dx on the left side, and the one that doesn't have dy dx will be on the right side. So right now, factorize dy dx. So we get this step. What you need to do is actually just transport ln 3x minus 4 sec squared 4y to the right side. Because remember, we want this in the final answer. This one. We want this one in the final answer. This is the form. So right now, so this is the final answer. So there's a formula for this question 3. Now we will go to the next question.
This is our last question. As you can see, this question asks us to solve linear approximation to estimate the value of square root 80.99 minus 2 over square root 80.99, and the answer need to be in the 3 decimal places. As you can see here, and we need to determine the x. The value of x has given at the question. As you can see, the x is 80.99, and the not x will be 81 because it's closer to the 80.99. And then we can find our delta x. Delta x will be our x minus with our not x. It will be equal to negative 0.01. After that, we can simplify our fx into the exponential form. Our fx will be x 1 power 1 over 4 minus 2 over x power 1 over 2. And we can substitute the value of x with 81. And we get 25 over 9. Or in decimal places, we can get 2.778. And then we can find our derivative of f prime x. And our f prime x will be 1 over 4x power negative 3 over 4 1x power of negative 3 over 2. And then we can substitute our value of x with 81. 1 over 4. And the answer we will get over 2,960. And then we can use the formula. Insert the value. As you can see, our F81 will be 2.778 plus with over 2,960. And our approximate value will be 2.778. I think that's all from me. Thank you.
In summary, we have learned several differentiation techniques based on the previous questions we worked through together, including the basic rules, product rule, quotient rule, chain rule, implicit differentiation, differentiation of trigonometric, exponential, and logarithmic function, and linear approximation to estimate values. As a concluding recommendation, I suggest being mindful of the specific requirements of each technique, especially for implicit differentiation, where careful application of the appropriate technique is essential. Remember to simplify the final function at the end if possible. For linear approximation, ensure the chosen value satisfies the conditions for accurate estimation. Regular practice of these methods will help solidify your understanding and minimize common errors.